This is an international event. Okay, so this is loading, but welcome everybody to data processing with Python, Celery, and RabbitMQ. Let me just go to the actual slideshow. I hope it doesn't. Oh, good. Okay, cool. Oh, because it's mirroring. Right, that's how it should be. So good. Welcome, everybody. This is a very hot room. I'm surprised there's no air conditioning, but I said it, so if we're all thinking it, now it's out. So my name is Jeff Peck. I work for a really cool company called Eserine. For those of you who were just in the last, just here before, Igor also gave a presentation, also from Eserine. This is, I guess, our room for the morning. So that's, and it's all right, even without the air conditioning. So today, all right, so yeah, first of all, yeah, our company, we have a fairly new company. We're about a year old, although we've all been working together for a long time before that. And we do a lot of search-related things. You can, Michael McIntosh here, you can talk to him after about the many hats we wear, the many things we do. All right, so the goal of this presentation. So what we want to do today, we hope to understand some real-life scenarios when processing data. Data processing usually does not occur in a straight pipeline. Usually there's lots of non-linear aspects. You know, things don't always process in a straight line. You have different sources, different dependencies, different targets, and things kind of rely on each other. Some things are circular. It could be a big mess. And that's what real-life data processing is. So we're going to try to understand some of these challenges. Then we're going to look into some of the solutions that we kind of looked into as we made our way to find our ideal approach, which is to use Celery. It's a library, it's a task queue, and it's a library for Python, which we found to be very good at dealing with data processing in the real world, where there's dependencies and all sorts of, you know, things aren't in a straight line. It uses RabbitMQ and Redis, and we'll talk a little bit about the different technologies involved. We'll learn about what these tools are, how they can be used. So don't worry if you're not familiar at this point, that's okay. And finally, we're going to go through a real-life example processing 500,000 emails, and we're going to take the example from scratch and bring you through the entire thing to completion in about 15 minutes. So that's the plan for today. And we have source code available on our GitHub account that, you know, you guys can explore when you have more than 15 minutes. So here we go. This is the agenda. I just kind of, it sort of covers the various goals that we had. Background, the challenge, the approaches we considered, going over what Celery is, task queues, and the practical example, and of course, ending off with some questions. So, some background. So we process data. Each week we process around 5 million different industrial parts that for an industrial parts website. And they come from all different sources. There's different formats. There's some structured data. There's some unstructured data, such as PDFs. The structured data itself comes from different sources. There's different types of catalogs. And all of this data needs to be deployed to multiple targets. We have a fast ESP search index, and we also have a MySQL database. And the data has to make its way to both of these things in some kind of constructive manner, you know, around the same time. It has to be really streamlined, and things should basically run in parallel.
Sorry, what's ESP?
Oh, good. So fast ESP is the search index that we use. It's a little bit out of date by today's standards, but it's still supported, and it's our client's search index.
Maybe like Lucene or Solr.
Yeah, exactly, just like Lucene.
Enterprise search platform, and it was purchased by Microsoft. It's now used as the SharePoint search backend.
Thank you.
So yeah, but we're not going to really focus on that aspect of it. The point is that that's the source. That's the target. One of the targets that we deliver to. In addition to delivering to these targets, we have to grab some additional information, like were the deploys successful for each individual item, to be able to report back to our client. We also have metadata that gets into the mix, and that's a dependency that has to be processed before anything else gets processed. So there are dependencies. And this has to happen every week seamlessly with a rapidly changing data set. If something goes wrong, we need to know about it before our client does. And so we basically needed a way to make the processing of this data as automated as possible so that we can focus more on development tasks. You know, we don't need to be babysitting this process every week. So we needed the right tools to make this happen. So this is just a sort of diagram of what very, very simple, simplified diagram of what our weekly processing cycle looks like. We have some structured catalog data. We have some unstructured PDF data. There's a metadata dependency, and the structured data goes to the database, MySQL, and the search index, which is FastDSP. The unstructured data just goes straight to the search index, but we have different processes that kind of have to combine the metadata and some common libraries and then output to similar sources. And it has to kind of all happen at around the same time.
May I ask a question?
Yes, please.
Going back to the diagram.
Yeah.
I assume that if, in the future point, you wanted to have some sort of heuristics or some way to turn that unstructured PDF data into more structured data, that you would add that to your pipeline in the same way you do your other processing?
Yes, I mean, part of the processing kind of does put it into a format that is more structured, and then, you know, that's why, like I said, this is a simplified diagram, but that's part of these gear-looking icons.
Yeah, for example, we break PDF documents up into individual pages so that we can serve those.
Yeah. So yeah, and then after all of these things complete, we also, I mean, it's not even on here, but we have to kind of say, okay, it's successfully made it into the search index and the database. Good, so that one's a success, and then we use that for reporting afterwards. So we have to kind of take these deploy operations and capture them as well on an individual item level, which, as Michael said here, it could even be a single PDF could go to multiple pages, and we have to consider each one of those pages in the reporting. So the challenge we have is to efficiently process the data from multiple sources. You know, we have various sources of data, and we want to streamline all of the processing. We need to consider all the dependencies, for example, the metadata that needs to be processed before anything else. And we are not supposed to make the MySQL data live until all the data has been deployed successfully. So these are just some examples of different dependencies that we have along the various parts of the build cycle. The actual deploying to multiple sources should occur close to the same time. And we don't have the requirement that it has to happen exactly at the same time, but it can't be more than a day off, because that will look strange on the front end if people are searching for something and the MySQL database is out of date or something like that. So it kind of has to happen in parallel so that these operations end up on the front end as close to the same time as possible. So we need to be able to also capture the success failure of each item, like I was saying. And this all needs to be easily triggered. We need to be able to just practically press a button or, you know, run a command and just let it go and not really have to babysit it. So just kind of going back to, all right, so our approach is, so originally when this started out, our approach was to basically process everything in batches. We didn't really have so much data, and we didn't update as frequently as we do today. So it was basically a safe way to ensure that the data made it through each stage. So we would, for example, process all of the catalogs. Then we would take those items and we would add some metadata to those items. We then put all of that into the database. We would then confirm that everything looks right in the database. And then we would push all of that to the search index. And, you know, it was a very slow process. The whole thing took about a week. And there were a lot of manual steps where we had to kind of, you know, look at it, inspect everything, and make sure that it looks right. It involved a great deal of manual interaction with the build cycle. And there was really a lot of wasted processing cycles on the server that we're running this on, because if you think about it, each time that it's waiting for something from us, it's idle. And then when things aren't running in parallel, all the more so. There's a lot of wasted processing time. In some cases, we had parallel processing, but, you know, it was rare. anyway, yeah, so it took almost a week to complete. So we started looking at other approaches. And the first thing we looked at was something called Pipes. Pipes is a tool that was written by Eric Gaumer and Matt Weber. And it's, I think both of them, or one of them, worked at FastESP. We took a look at it. And it's a library that basically implements the flow-based programming paradigm. Uses stackless Python and tasklets to efficiently run things in parallel. It's basically it can take advantage of real parallel processing, which standard Python cannot. And because it's the flow-based programming paradigm, it had components, and it had what was the other
Packets.
packets? Thank you. That's what I was looking for. Components and packets. There you go. So yeah, basically a component was like a library or some kind of module, some kind of black box, and some data would go in a packet, and if something would go out. So you could imagine like an item goes in, it gets processed, it goes out. We found it a little bit hard to work with in our case because we had like things like PDFs that had multiple pages going out and catalogs that had multiple items coming out of them. And it wasn't really set up to work with that, even though it was very good at other kind of nonlinear tasks like multiplexing and the like. It just was not good at dealing with that. And we found it wasn't really very well supported. As of today, I think it hasn't been updated in over 3 years. And so it's kind of like, for a production purpose, we realized it wasn't really right for us, but it kind of put us on the right path of what we want to do, how we want to structure our build cycle. And with this idea in mind of pipelines and things being nonlinear, but still, having dependencies and being mindful of them, that kind of led us to the next logical approach. And that was, this calls for some celery. That's Linny from the Wonder Pets.
Yeah.
And I'm not sure if you're familiar with the Wonder Pets, but it's a children's show. Linny's catchphrase is, this calls for some celery. And Linny was correct, because this task did call for some celery. Celery is a distributed task queue, and it's written in Python. It integrates with a number of message brokers and backends, including RabbitMQ and Redis, and we'll talk a little bit about them as we go. Now, important thing, a big thing, it supports task chaining, as well as task grouping and chords. So an example of a task chain might be one task completes, and then another one runs right after it, straight pipeline. But then you get into things like chords, and that's, let's say you have 3 different tasks, and they all need to complete, and once all 3 of them finish, whether success or failed, it then needs to do something else like log the result or send an email or something like that. So the fact that it supported things like that right out of the box was made it perfect for what we want to do.
A quick question, is that an abstraction that's above RabbitMQ?
Yeah, I mean, the entire library is an abstraction above RabbitMQ. I think, working with RabbitMQ directly, you might be able to do things like this, but it would take a lot of effort.
That's what I'm trying to ask you.
Yeah, whereas this is literally a one-line function to group and make chords and things like that. So yeah, that's the idea. It's very flexible. It offers many different ways to use it. In our case, we're using it straight with Python, but tasks can be instantiated in a number of different ways and can be called. Even if you don't have Python or you're not using Python directly, you can actually call tasks using webhooks. So it really, it spans a lot of possibilities for solutions to different problems. It also doesn't just work with RabbitMQ, but it works with Redis and IronMQ and MongoDB and a whole variety of other different backends and message brokers. So that's Celery, and it has a very active community too, over 10,000 downloads a day. So that's pretty amazing that there's that many people downloading.
We've had some questions, and I think the people that wrote it got back to us really quickly.
Oh yeah, I've posted questions on years ago when we started working with it. I would post a question on Quora or Stack Overflow, and the guy who wrote Celery would respond to me within an hour, and we would have long conversations back and forth. And so yeah, very, very active community, and nice to get responses straight from the developers. So a little bit more about Celery, as it says, as they say on their website, it's an asynchronous task queue or job queue based on distributed message passing. It's focused on real-time operation, but supports scheduling as well. So in our case, we're using it for real-time, but you can use it to replace cron tab in many cases. So it can be downloaded here, or you can just do pip install Celery, and you can get it that way. I think the things I said previously were related to this slide about the task chaining, the callbacks, and it really was ideal for us. So all right, so just very quick, we'll define some terms. So what is a distributed task queue? So we have, first of all, a basic concept of a message queue. That's something that just passes messages back and forth between systems or on a single system. An example might be a Jabber client or AOL Instant Messenger or Facebook Messenger or Google Hangouts Messenger, any kind of messaging client that's sending messages back and forth. You know, the idea is a message goes, it sits on the server, it waits in a queue, then some other application comes and says, hey, I'm looking for that message. It drops out of the queue, and that's pretty much what a message queue is. Then we get into a task queue, which is a type of message queue that deals specifically with tasks. So for example, you might have YouTube, you upload a video to YouTube of, I don't know, penguins bowling, and then you want to wait for that to be processed, but you don't want to sit there and wait. So eventually on YouTube servers, Google servers, they process the video and they send you an email and they post it to the site, and that all happens in the background asynchronously because it was sitting in a queue and eventually got processed. In the case of YouTube, they then might send it to a secondary queue, which will do some, you know, DRM, like, you know, search for copyright infringement and the like. And, you know, all this kind of stuff happens in the background inside task queues. Then we get a distributed task queue, which is what Celery defines itself as, which is basically just lots of different task queues that are combined together on multiple systems. They could span multiple systems and kind of joined together with different workers. So what are these workers I speak of? Well, Celery has workers, brokers, and backend. So a worker is something that executes tasks that are passed to it from the message broker. Let's see if I'm okay. So yeah, so it's basically like a long-running Python application that just sits there in the background, and anytime, you know, it's looking at a queue, and anytime a new message comes into the queue or a new task comes into the queue, the worker will grab that task and get to work. Then the message broker is the service that sends and receives the messages. That's what we just said in the previous slide. So that is like, that would be RabbitMQ. It could also be Redis, MongoDB, IronMQ. There's a whole list on the Celery website of various ones that are supported, but these are just some of them. And then we get to the backend. Now the backend is really only necessary if you need to store the results. It is necessary if you're doing grouping or chaining and you need to confirm that the tasks came back, and with a cord anyway. So, but it's also useful if, let's say, you want to run a lot of different tasks and store the results somewhere to be picked up later. That's what the backend is for. And in Celery, it's recommended to use Redis as the backend, but once again, you can choose from a variety of different backends. And it all depends on your various needs in terms of performance, what kind of tasks you're doing, how many tasks, etc. So that is the worker, message broker, and backend. Let's see. So now we're going to get into the practical example. Stray bullet. How about that? All right. So yeah, we have 500,000 emails that were recovered from Enron servers. I guess after Enron went down, that was about 8 years ago or so. Before we get to the practical example, are there any questions at this point? Yes.
I have a couple. In terms of the serialization format for when these messages are going into RabbitMQ, et cetera, I mean, is it plain text serialization, so it's easy to inspect? Is it binary blobs? What's the serialization format?
Great question. So they are, as of the latest version of Celery, they are pickled. However, that's been deprecated for using JSON. And I guess the most recent version, but they still support the old pickling of data.
If you're wanting to end up, for instance, having an endpoint being another RabbitMQ topic or queue that might be in some serialization format that like someone processing in a different programming language could do, is it fairly easy once I'm getting out of Celery lambs to like broadcast to a RabbitMQ topic? They'll be picked up maybe by consumers in different languages?
Yes, absolutely. Yeah, one of the things you can do when you instantiate your Celery instance is you choose your serialization format. And I mean, I don't know if you can, I assume it's possible to write your own custom serializer, because essentially you're just, putting in a serialization format. You could write your own class and wrap it appropriately. It might even be covered in the documentation.
So we had to make 2 custom endpoint connectors, one for writing to MySQL and one to writing to a proprietary commercial database engine. So even if Celery out of the box doesn't support the serialization format that you want, you can easily write code as long as the code can generate whatever and use that as an endpoint. So it serializes it for you in whatever format you want.
And I know IronMQ, I know for like Windows users, IronMQ is the go-to message queue, just like RabbitMQ is for Linux, as far as I understand. I'm not a Windows developer, but that's my understanding anyway. And yeah, that's already, that is pre-built, and that might have its own serialization format, I would suppose. So here we go, right to it, the practical example. So for the rest of this presentation, I will go over a practical example that I put together specifically for this presentation here at the Nerd Summit. All of the code that I will present is available online at our URL, github/Eserine, and you can click on the link. It says Celery data processing. The goal is to take 500,000 emails that were recovered from Enron servers and then deploy them into Elasticsearch and MySQL. Elasticsearch is just another search index, very easy to use out of the box, and MySQL, I think we're all familiar with, a database engine. So a hypothetical use for this, you might have something on a front end where you would query for full text searches in Elasticsearch and then pull up the results in MySQL and do some other kind of query, or mix it together with some metadata on the MySQL end. There's a lot of things you could do with this. You could, make all sorts of engines to search through the Enron emails. But for this practical example, we're just going to worry about the processing and deployment. It looks a little something like this. You got the emails, they go in, they get parsed, they go there and there, Elasticsearch and MySQL. And that's all we're going to do. It's pretty straightforward. And we're going to see how we can do this from scratch in Celery. So let's see how we're doing on time. Pretty good, 11:25. All right, so starts out with just an initial setup. Like I said, I'm taking you through it from scratch. So you need to install RabbitMQ. If you don't already have these things, I used a Ubuntu server, so I used apt-get, install RabbitMQ, Redis, Celery, Fabric. Fabric is a tool that we use to actually run these things. I won't get too into it in this, but you'll see in the example how we're using it. Elasticsearch, there's a bunch of steps to install Elasticsearch, but you can, this is just copy pasted off of the Elasticsearch website. It's not, you have to install Java first if you don't already have that, Java 7, and then you have to actually start it at the end. Anyway, these are things that you can literally follow the example. All of this is also listed on the GitHub repository. So if you were to start from scratch, you would have all of this. And then to install MySQL and the Python libraries for that. And very important, create the messages database in MySQL. Even if you already have this stuff installed, you have to do this part. And then you're ready to go to start this. So you'd create a new directory for the project. I called it Celery Message Processing. And then we create a proj directory. That's the Celery project. And by convention in Celery and all the documentation on Celery's website, proj is the name of the project directory. You can call it whatever you want, but we keep to the convention. And then you just put inside of it an empty init.py file. I'm not sure if everyone's familiar with Python and making Python modules, but putting an empty init.py file basically lets Python know that this directory can be accessed as a module and be imported. It's a standard thing in Python, even though it looks kind of funny. And finally, you download the raw Enron emails. They are maintained at this address, and you can get that off the slides or also from the GitHub page. And then you unpack the emails, and you're ready to go. So we start. This is the Celery file. This is kind of like the thing that pulls everything together and lets Celery know, its surroundings. So, and this is where you would do things like set up serializers and the like. So you import this and then the Celery library. This is where we tell it that this proj directory is important. The broker is AMQP. That basically means RabbitMQ. That is the protocol for the RabbitMQ. Then the backend is Redis, and that we specify. We pointed at localhost. I think if you left localhost out, it would still work, but good to leave it in. And finally, we include the tasks file, which we're going to. I'll show you next. Then we have the configuration here, and this is where you do things like add your own serializer. And really, if you look on the Celery documentation, you can do a lot. I mean, in production, our configuration is big. So here, all we're doing is just setting one thing, that the result should expire in 3,600 seconds from the backend. And that's it. Then we call app.start, and that's our celery.py file. Now the tasks file, that's what we get to here. This is kind of the meat of the project. This is the whole project here. And this is actually going to span 4 slides. So we just get our imports out of the way. We're going to use the email, Python email library for parsing. It's a one-liner to parse an email file. We use SQL Alchemy for our MySQL inserts, and Elasticsearch library to insert things into Elasticsearch. Then we import the task class. We're going to use that. You'll see how we use that in the next slide, and the Celery app itself. So this is our task. Can everyone see that, or is that way too small? Okay. Well, I'll describe it. So we are initializing a base class called the messages task. And this is a general purpose class that's going to do everything that we need to do for the processing and deploying. In our actual production, what we do in our in our company, the actual production thing that we do, we have a number of these base classes, and they all have different purposes. Here, I just put it all together because this is really basic, and it would just make things messy to make separate base classes. So it has a bunch of initializers. Basically, we don't want to run, we don't want to reinitialize a database connection for every single database insert, and same thing with Elasticsearch. We also don't want to make a global database database instance, because doing that, then every time we want to do an insert, we can have some collisions, and things can get messy. Unless, of course, the library is thread safe, which I don't think it is. So, just to keep things safe, we make sure that we initialize one instance per worker, and then everything's fine. So to do that, we have some functions like init database, init Elasticsearch. Init database just puts a reference. I know it's hard to see from here, but these are just all of the columns in the messages table, and then we set it up. And that's that. And same thing with Elasticsearch, except we don't have to actually set up columns. Yes.
Do they come from some package? These Create Engine and other SQL tools. What package are you using to get?
Well, oh yeah. So this is SQL Alchemy.
Okay.
Yeah. So it's SQL Alchemy.
Imported everything.
Yeah. Basically, yeah. And we defined the table right there. So yes. And then these are the actual functions. So the parsing message, you can see it's a one-liner. Well, you can't see because it's so small, but one-liner to grab the message from a file, and then we're basically just making a Python dictionary and returning that. That's our actual function or method to parse a message. Then we have a method to do the database insert, and that's a couple lines. basically just takes a dictionary and puts it in. First initializes it if it's not already been initialized. Same thing with Elasticsearch. If it's not already been initialized, we initialize it, then call this one-liner, and we put our message into Elasticsearch. So these are all of our methods. Now, how will we actually access these methods is in the next slide. So we have, and this is the last part of the tasks file. So we have these 3 functions, and they're exposed as with the decorator app.task. It says that it uses the messages task that we just showed you as the base task, and it's part of the parse queue. And then all it does is this one thing. It just calls the parse message file, the base task. Next, we have the deploy to the database task, which uses a different queue. It also is set to ignore the result. We'll talk about that in a little bit if it comes up. And same thing, it's just a one-liner. And also to deploy to Elasticsearch, I call it deploy ES. And same deal. It's a one-liner, just calls a method from the base task that I just showed you in the previous slide. So these are pretty straightforward. They might need to be looked at more closely if you were to download the source code and you could see it all and experiment with it and run it. And I highly encourage that everybody do that. But these are the tasks. I will talk about the ignore result now. So as I mentioned, there's a back end. And if you say to ignore the result, you're basically saying this doesn't return anything, so don't waste time putting it in the back end for it just to sit there and not get picked up. I'll show you in the example, we're not really doing anything with the results. Whether or not they succeed or fail, we're not doing anything with it at the moment. If we were to modify this code to actually do something afterwards, like report it or send it to a log or an email or something, we would want to turn that off. But we leave it on now because it's not actually doing anything with the result. Are there any questions here before I go to the next slide? Yes.
A couple. I'm noticing that you're specifying the queues for this thing. What I'm not seeing is how the hookup is happening between results being propagated to the next queues. Is that coming up?
That is going to come up. That's actually on the 2 slides from it. Yeah, basically the next.
At least for your parse task there, getting picked up with a file name, I would assume that when you have shared resources like files that are getting parsed or any sort of other sort of physical stuff that isn't inherent in the task definition itself, like the file contents are in the queue, right?
Yes.
You would have those in some sort of shared storage that would be accessible from all of your various tasks that need to access the file?
Yeah, precisely. Like we might use, we might have another Redis database or something where we're picking it up. If this was spanning multiple servers, yeah, we wouldn't access it from a file path. We would access it from something more global.
Yeah.
But it is still better. I mean, we've experimented with actually passing entire blobs. I mean, like, giant XML files. And it seems to be better to pass a reference because otherwise you're pickling this giant string each time it gets serialized and unserialized. Seems better just to pass some kind of reference, whether it to be a database or something like that. Actually, yeah, we use React for a lot of our processing in production, and that's where we keep things. So, all right, so the next thing is, and this is the last file you're going to need, is this fabric file, which is the file that you use to run all of these things, to put it all together. Once again, we have some basic imports. And just so you know, Fabric is it's kind of a little bit to Python as what Ant is to Java. It's sort of, do you think that's an appropriate?
I mean, Ant manages dependencies like, make does. So
yeah,
it's
maybe
kinda
that's
like, it's kind of like a make, but it's very powerful. It makes it easy for you to make basically command line tool to like build stuff.
There you go. Yeah, so we use it a lot. You don't have to use Fabric. I'm just using it because I think it's convenient, and maybe you will too. So we import our parse deploy-db and deploy-es tasks from the task file, as well as the chain and group functions. We also import inspect, but I'm not going to go into that. So, but you can look at that in the if you download the source code. So then we have our first function, which is to actually start the workers. all this does is it runs locally this command, Celery multi, and then it instantiates the parse db deploy, es deploy, and Celery. These are all different queues, and then we specify or actually these are workers, and we associate the worker with the queue. You know, so it's kind of a long and arduous thing to type every time. So rather than type it out each time, we have a Fabric function where all you have to do is call fab workers start, fab workers stop, workers restart, and it will execute this and format it properly. In production, we have a lot of other things. We actually have in Fabric, you can configure, for example, how many resources you want to put. So this Celery multi command is very powerful. You can say you want, for example, here we actually are having a concurrency of 2 for our parse queue, our deploy queue, and both of our deploy queues, database and Elasticsearch deploy. And for the Celery queue, which is just kind of like the manager, it runs kind of certain tasks in the background. We only have a concurrency of 1 for that because we want to really use all of our resources for the actual substance of what we're doing. And you know, you can configure these things however you want. You can say, you know, for the Elasticsearch deploy, you want to have a concurrency of 8. That means 8 different workers working all at once. You can really get into however you want to configure this, but we're keeping it simple here, and start, stop, and restart are the 3 things that you can do from this.
So Fabric also, like workers is a task, or is it a job? What is that?
So yeah, a worker.
In Fab, that's a task.
Oh yeah, the task name
Right.
is workers.
So a task can have multiple params. So if you wanted a task, if you wanted to specify something else about how the task is executed, you could, there's a way to pass in multiple parameters. That's why we like Fabric so much.
Yeah. Like you could say Fabric workers start and specify that you want a concurrency of 8 for, you know, you can get into lots of things to configure it. But of course, then this function would be much longer and it wouldn't fit on this slide. So we're just keeping it simpler. So that's that. Finally, we get to the actual task chaining. So just ignoring this for a second, this is basically it. Process 1. It's a Fabric function that will process a single file name. Basically, it enqueues this processing task. So the processing task starts with parse .s in the file name. So .s is a Celery kind of short syntax to asynchronously start processing this thing, to basically put it into the queue. And then the .s, it will basically return a reference to the task itself. And you don't really need to think too hard about what's happening in the background in Celery. This is just the notation that is used, and you can use it. So parse.s, we're chaining together 2 things, parse file name, and then a group of the deploy to the database and the deploy to Elasticsearch from whatever gets chained and passed into these things. So the file is parsed, and then it kind of goes to the database and to Elasticsearch from this group function, and both of those get run in parallel, you know, simultaneously, and then the result, which in this case is going to be none, but is nonetheless as a result, is passed to this. And then just for the sake of you know, seeing what's going on, I have it print enqueued a mail file for processing. If you're actually going to run this on all 500,000 files, I suggest commenting out that line because that will be really annoying otherwise. Anyway, so that's it. Then I just made a convenience function here to process, and you point it at either a file or a directory. And if it's a directory, it will recursively walk through the directory and run this thing on all the files. So that's it. So at the end with all this, all you have to do to run your build cycle is start Celery. And once it's running, you don't have to ever start it again. And then just run fab process and point it at our mail directory. That's where the 500,000 emails are sitting. And they'll all nicely go into the queue. And they'll start getting picked up by the workers, and they'll get passed along. And very soon after, you should start seeing your database and Elasticsearch instance being populated with lots of Enron emails.
And if I understand this correctly, if you had multiple mail directories, you could call process Melder 1, Melder 2, Melder 3.
I think so. I mean, that's really just a function of how well.
Yeah, they'll get in queued.
Oh, right. I mean, currently they would not, but if I were to, let's say, instead of saying path equals none and accept a string.
No, I mean calling the command separately, it would include.
Oh, yes, exactly, right. Yeah, if you were to do process, yes, exactly.
Yeah.
And then it would enqueue each one. And you're not waiting for it to return. Processing could take a couple hours, but this command here will run asynchronously and will hopefully return in a couple seconds, or all 500,000, maybe a minute or so, but nothing serious. Yes.
Can you go back?
Yeah.
So the chaining there from the parse to the grouping there, for error handling, with a group like that, I mean, obviously there's no true quote-unquote distributed transactions or anything happening here. So if in your grouping that you're deployed to your DB fails for whatever reason, MySQL goes down, the file system fills up, whatever, unexpected thing happens, is there actual sort of API and functionality for specifying rollbacks in groups? Let's say
yes.
the group fails, will the other task have an ability to realize that part of its group failed, so it should stop or roll back? Like, how is this sort of error handling?
Yeah, exactly. So first of all, going back here, if we were to take this ignore result and leave it out or set it to false, by default it's false, but if we were to make that false, then over here when we run this group, basically it would, then we could do something with it after. We could have another thing in the chain, or we could basically run a cord, which is the same thing, or we could even attach an error handler. And all of these things are basically different shortcuts inside Celery to do the same thing, which is to take the result of this, the combined result of these, whatever gets executed in the group, pass it along to something else which can evaluate and say, oh, something failed. Let me do something else now, like send an email or.
So that would be an additional task for, let's say, rolling back Elasticsearch because MySQL doesn't have.
Yeah. Right, to roll back, exactly. Yeah, that would be an additional task. And it would be very good to make something like that a task rather than just a one-time function, because then it gets put into a queue. And if, let's say, something else fails, when you try to roll back, the rollback fails, it'll just, it will just basically stay in the queue. Your queue is hopefully durable. If you're using RabbitMQ, it gets saved to disk, I think, regularly, maybe every couple times a second. So hopefully, as long as nobody pulls the plug on the server or something, it's going to be sitting there in the queue, and it will eventually make its way back to it to roll back.
You can specify, there are ways to specify how many times it can retry something or how many times it can fail before it gets routed to something else.
Yeah, exactly. And there's nice examples in the Celery documentation. It's really versatile. You have a lot of control. There's you can basically call the raise function. I mean the raise raise operator inside a Celery function and have it call a special function that tells it to retry if the number of retries hasn't already been met. So yeah, you can really do a lot of you can really get very into exactly how you want it to run. A lot of possibilities. So that's the usage. And yeah, as you mentioned, we're saying what's next. So that these are some of the things that you can do after this. You can trigger a task to update an email status, like a message that you're processing status after it successfully is processed and deployed to MySQL and Elasticsearch, or of course if it fails, to do some kind of rollback, send an email. You can also log every time an error occurs with a special custom error handler. And finally, you can actually detect the completion of everything. You'd have to do this with some kind of scheduled task to basically check, because you're not going to run all 500,000 messages in some kind of group. That you don't want to try that. But what you could do is have something basically check every 5 minutes or so. Is it done yet? Is it done yet? Is it done yet? And once it's done, and that's where Celery scheduling kind of can be a handy feature.
So you could have something like the reporting tie into like a dashboard. So that it runs once a minute. That would be like a schedule, runs once a minute, generates a summary of where it stands with the current set of tasks.
Yes. Yeah, and you can look at the tasks, and also you can even just evaluate your deploy targets, like what's actually in the database. And you can get practical about it. And I encourage everybody, try it yourself. You can go here, Eserine, and there's a full path or just go there, and click on it. You can, fork the code and make your own project. It's actually a great boilerplate if you want to start working with Celery. You don't really care for processing Enron emails. Just download the code and, write your own functions to process something else. And it's really a great boilerplate for any Celery project. And feel free to ask questions and email us, and we'll have a good time. All right.
Are
Yeah.
the slides going to be available?
I think, yeah, we'll put them on, yeah,
We'll make them available.
I think SlideShare, we'll find some way to make them available. I'll probably,
The Nerd Center website also has a slide upload you can do for your
Oh.
talk itself, so you can upload a file that way too.
perfect, then that's what we will do. One more thing, speaking of reporting, just something to be aware of, there's a nice tool called Celery Flower. It provides real-time reporting of your, what all your workers are up to, the different queues, how much usage is happening, and the like. And it's a kind of nice thing to have a web interface, especially if, let's say you have a client, you want to just show them, this is what's going on with the build this week, and you can point them at this, and you don't really have to, put them in front of a terminal or something. It's also a handy tool, I guess, to have for really anybody. So it's called Celery Flower, and you can download it there. That's it. Any questions? It's a pun. I couldn't find a picture of celery.
Asparagus works.
Yeah.
I'm sure that's probably another tool.
Yeah.
Where did the name come from?
Look at that, 11:49. Yeah. All right. Great. Do I do something with the Google Hangout?
Yeah, I don't know.
I think you can just end it.
Okay. Cool.